Hey guys, welcome back. This is our next lesson, which is about binomial probability. So binomial probability is a pretty cool concept, and it's used to figure out like the probability of having a specific number of successes in an experiment. You'll see exactly what I mean when we do some of these example problems. So let's go ahead and jump right in. Please make sure you're filling in your name and date and period at the top of your notes before you submit them, so I can tell them apart. And let's get started. So a binomial experiment, I'm going to use my highlighter here, consists of n independent trials. So you repeat the same thing n number of times. So like, let's say for example, it's like a coin toss. You're going to take that coin and toss it one time, and that's a trial. Well, let's say you're trying to figure out how many times you're going to be able to get heads if you were to toss it 10 times. So that's 10 different trials because you're repeating the same thing over and over again. So in a binomial experiment, there's only two outcomes, and that's either a success or a failure. Success and failure. And the probability of a successful outcome is going to be labeled by the variable p, and it's the same in every trial. And then the probability of failure will be q, and that's the same in every trial. So if you think about it with that coin toss example I just gave, let's say that we would consider that if we toss the coin and we get the head side, then that would be a success. And if we got the tail side, that would be a failure. So then there's only two possible outcomes, so you have a 50-50 shot. Therefore, the probability of a success, or P, is going to be 0.5, and the probability of failure is going to be 0.5. And those numbers will change depending on what's happening inside of your experiment. So the probability of success is going to be given by P, and then the probability of failure is Q, but you can find that by taking 1 minus P, okay? So that makes sense because let's say you have a probability of a success that's 0.25 or 1/4. Well, if 25% of the time it's going to be a success, then that means 75% of the time it's going to be a failure, and therefore Q will be 0.75 or 3/4. Okay, so let's see if we can do some experiments here. This is just finding out what P and Q are. So the experiment for the first one says randomly selecting a particular month 30 different times. So to be considered a successful experiment, we would have had to pick January. And for it to be a failure, we have to pick any other month that's not January. So how many months are there altogether? Well, there's 12. So we have a possibility of success 1 in 12 times, because a success would be choosing January, and that's only 1 out of the 12 months. And then for failure, that would be 11 out of 12, which you don't even need to do the math for, but if you were to do 1 minus 1/12, you'd get 11/12 left over. Okay, second experiment is randomly selecting a particular card 100 times. And that it's going to be a success if we choose a heart, and it's going to be a failure if we choose something that is not a heart. So if we think about a deck of cards, there's 52 cards, and how many of them are hearts? There's 13, okay? So that would be 13 out of 52. And the probability of failure would be anything else, which is going to be 39 out of 52, because there's 39 cards that are not hearts. Now, I'm pretty sure that these reduce because there's 4 suits, so it should be 1/4, yeah. So this is actually 1 out of 4, and then that would make this one 3 out of 4. Okay, so let's actually apply this now and actually do some probability experiments. So the first thing we're going to be looking at is the formula that we have to use. Now I'm going to caution you now and say that there is a really, really simplified, easy way to do this on a graphing calculator, okay? And so if you have a graphing calculator, that's great, use it. If you don't worry, because I'm going to post actually a separate video that gives you some other resources that you can use to do this. And mainly there's actually free apps you can download on your phone that act just like graphing calculators. Or if you're on a Windows computer, you can download a graphing calculator emulator, and it will do all of these things will do the same functions. They might look slightly different from one another, but generally the process is the same. So I'm going to record a separate video that goes over how to do that. But for now, we're going to use the formula. So the probability of if an experiment has n number of trials, that's you repeating that experiment over and over. P is the probability of success, Q is the probability of failure, and the binomial probability is that there will be exactly R successes. Okay, so this is a key term here, is that it's exactly R successes, because we can do this two ways. We can do this where it's exactly that many of successes, or we can do like a cumulative probability, which would give you at least that many successes. So we will get to those later. Right now, that we're just working with the exact ones. But the formula you're going to follow is you're going to take the combination of N and R. So how many trials resulted in that many successes, and you're going to multiply this by the probability of success to the power of R, and you're going to multiply that by the probability of failure times N minus R. So all in all, this looks like a lot of, stuff to do, right? There's a lot of things happening, but if you remember two things: one, the combination formula or how to calculate a combination. We did that a couple sections ago, okay? If you can do that and you can figure out what N, R, P, and Q are, you have everything you need. You just plug it in and you solve. So let's go ahead and do some examples. So we're going to work on the first one, which is that. Now remember, this is the section here where there is an exact number of successes. So I'm highlighting this over on the side. There's an exact number. So the process is a little different if it's at least or at most a certain number of successes. But right now we're just looking at where it's exactly that many successes. So example 1, Mark tosses a coin 25 times. What is the probability that it lands on heads exactly 7 times? Okay, so keyword here being the word exactly. Okay. Remember, N is the number of trials. So how many times did he toss this coin? 25. So N is 25. And the probability that it's heads. So remember, in a coin toss, there's only 2 sides, so it's 50-50. So the P is 1/2, and the Q is also 1/2. And all you really need to figure out is R, which is how many successes you're looking for. Well, in this case, R is 7 because they told me I'm trying to find out the probability it lands on heads exactly 7 times. Okay, so now we just plug it into our formula. I will go ahead and switch colors. So we plug into the formula and we get 25 combination 7. That's multiplied by 1/2, which is P, to the power of R. R is 7. And we multiply the failure rate by N minus R, which is 25 minus 7. So we can actually plug all of this into our calculator, and I will bring that up on, hopefully you can see this. Looks like you can. So first we're going to do 25. We're going to go to our probability and do combination of 7. That answer we're going to multiply by 1/2 to the power of 7. Ooh, I messed up. I have a syntax error. Oh, I think I have too many parentheses. That's what happened. Okay, so let me clear that and do it again. Probability combination 7. We're going to multiply this by 1/2. I do want 2 parentheses here. 1/2 power of 7. And then close that. There we go. Okay, and then we have one more thing to multiply that by. That's 1/2 to the power of, well, what's 25 minus 7? It's 18. And there you go. Now, this is a decimal, right? So you can put your answer in a decimal form if you want to. It would be 0.014-ish. Something else that you can do, which probably makes the answer sound more tangible, something you can, like a concrete idea, is you can multiply this answer by 100 and turn it into a percent. So the percent probability is that I have a 1.43 approximately percent chance that in those 25 coin tosses, exactly 7 of them are going to be on the head side. So let's write our answer out here. The answer is 1.43%. Okay, so let's go ahead and switch to the next example. Next example is about the spinner. The spinner below is spun 10 times. And what's the probability that it lands on red? Exactly 6 times. So let's do some fact finding here. So how many times do we spin it? That's the number of trials. Well, that's 10 times that we're spinning the spinner. And the probability of success and the probability of failure and the number of outcomes we're looking for successes is 6. They told us that right here. It's exactly 6 times. And so let's figure out probability of success versus failure. So it's a success if it lands on red. So how many of these spaces are there? There are 6. And how many of them are red? That's 2. So that means 1 out of 3 times, which is like 2 out of 6 reduces to 1/3. So 1 out of 3 times we have a success. That means 2 out of 3 times we have a failure. Okay. So we have everything we need to do our formula. So let's do it. It's going to be 10 combination 6 times the probability of success to the power of 6, that's R. And then we have the probability of failure to the power of 10 minus R, which is going to be 10 minus 6, which is 4. And all of this is going to give me some kind of percentage, so I'm going to use my calculator for this. Let's go back. Okay. We're going to go ahead and punch in 10 combination of 6. That answer is going to be multiplied by 1/3 to the, oops, I didn't type any numbers, cool, 1/3 to the power of 6. And that answer is multiplied by 2/3 to the power of 4. And that's it. We're going to multiply it by 100 so it makes more sense to us, this number. That means our probability here is 5.69%. And that is our answer. So if I spin the spinner 10 times, exactly, and how, okay, so the question is, what's the probability that I will land on red exactly 6 out of those 10 times? Well, the probability is 5.69%. And think about that. That makes sense. For me to be able to get that spinner to land on red 6 times out of 10 times, that's a large margin, a large amount of my spins landing on only 2 of those spaces. So it makes sense that my probability is pretty low, 5-something%. That's a really low probability. If this probability was like 90%, then I'm like, oh, well, that makes sense. Like I'm gonna land on it a bunch of times. But this number fits in with this scenario. It's not likely that I'm gonna be able to get, this spinner to spin out of 10 times, 6 of them landing on only these 2 spaces. It's not a high probability, if you think about that. Okay, so let's go to the next. We have 2 examples here we're gonna work on, and then I think you have some on the next page. So, let's take a little iced coffee break right now because, we need some coffee, and I'm going to drink it out of my Florida Gators Tervis. Go Gators. Just like in class, right? Okay, So next example, Kate took a multiple choice test and guessed on the last 5 questions. Typical. What is the probability that she got exactly 3 questions correct on those last 3 questions that she guessed on? Okay, so notice they didn't tell you anything about how many questions are on the test, because we don't care about the whole test. We care about these last 5 questions. So if you imagine this scenario as a probability, every question that she answers, which is 5 of them, is a trial, because you're either going to get it right or get it wrong, okay? So the N, oh, this is supposed to be orange. Like, what am I doing? Let me switch this over. The N is going to be 5, because there's 5 trials, and the R will be 3, because the exact successes is supposed to be 3. The next thing you have to kind of consider is, in each question, how many answer choices are there? Because how else would you know if it was a success or a failure? What would be a right answer out of how many choices? You know, that's the thing you're missing here. I mean, really, this question did not give you all the information that you need. They should have told you how many answer choices there were in each question. I'm gonna go with 4, because let's just say that the answer choices are A, B, C, D, and only one of them can be right. Okay. Hopefully, if you get a question like this again, it will give you, where you don't have to like assume anything. But we're gonna assume that there's 4 answer choices. So that would tell me that the probability of a success would be 1 out of 4, and the probability of failure would be 3 out of 4. So let's solve this. That would be a 5 combo of 3 times the success probability to the power of R times the failure probability to the power of N minus R, which is 5 minus 3. And when we figure all this out, we're going to get a lovely percentage rate. Let's do the calculator again. Make sure you can see all this. Yeah, cool. Okay. So 5, combination 3. We multiply that by 1 out of 4. Whoops, I want more parentheses. You might be saying, you don't need that many parentheses. I absolutely do, because I really want to make sure the calculator, this is why I'm doing this, by the way. Let me point to my calculator here. I'm doing this because I want to make sure the calculator does 1/4 to the 3rd power before it multiplies anything by the answer that I got in the last question, okay, before it multiplies that by 10. That's why I'm doing so many parentheses. I'm nesting them in so that it does the calculations in the right order. Okay, and then that is going to be multiplied by our failure part, which is 3 out of 4 to the power of N minus R, which is going to give me a 2. And there you have it. Multiply that by 100. There's an 8.79% chance. 8.79% chance that when Kate guesses on these questions, she's going to get exactly 3 of them correct out of the 5 she guessed on. Okay, last example for the exact successes, and then I'm going to set you loose to do some. Chad randomly chooses a card from a standard deck 30 times. What's the probability that he gets a diamond exactly 4 times? Well, the number of trials here is he's doing this 30 times, and our successes is 4. The probability of a success is going to be, well, how many diamonds are in a deck of cards? There's 13. And there's 13 out of 52, which we already said if you roll back up here. This whole example right here told me that there were 13 diamonds out of a deck of 52, which is 1/4. And if the success is 1/4, the failure has to be 3/4. So that's what's left up to 1, okay? Let's do our red color. And we're going to do the math for this, which is 30 combination 4 times our success rate probability to the power of r times the failure probability to the power of n minus r, 30 minus 4, which is 26. Okay, so my answer here, that's an arrow that I'm drawing, by the way. It doesn't look like an arrow, but I promise it is. Okay, so 30 probability combination menu. Okay, multiply this by 1/4 to the power of 4. Multiply this by 3/4 to the power of 26. Multiply my answer by 100 to get a percent, so I have 6.04%. Okay. All right. So if I roll to the next page, okay, this is page 2 of the notes, you'll see that the top 4 problems here is all classwork, all right? Class work. That's the ugliest handwriting I've ever seen. That's not true. Okay, so classwork. Here you go. These 4 problems. Make sure when you turn these notes in that you have done these classwork problems. Give them a shot. Show your work. If you don't have all this stuff written on your problem and you just write an answer, I'm going to take points off because you didn't do the problem like I showed you how to do the problem. Okay, so the last part here, there's only 4 questions. I'm going to do 2 of them. You're going to do the other 2. The last part of the notes here is about at least or at most, okay? So what's happening here is that instead of saying I'm gonna get tails on this coin toss exactly 4 times out of 10, you're saying what's the probability that it happens at least a certain number of times. So let's just look at an example and do it. Kyle tosses a coin 10 times. What's the probability that he gets tails at least 8 times? So that means we have to combine probabilities. We need to combine the probability that it happens 8 times, that it happens 9 times, and that it happens 10 times, okay? So there's quite a little bit of math happening here. You're going to have to sort of like sort this pattern out in your head as you write this stuff down, okay? And then make sure you're doing it all. Okay, so let's define some stuff. The first thing is n, which is 10 experiments. He does the experiment 10 times, the 10 trials. What's the probability? Well, what's the success, right? So it's a coin toss, so the success is 1/2 and the failure is 1/2. And I can't really define R just yet. Well, I can. So R is, if it's at least 8 times, R has to be greater than or equal to 8. It's not going to go over 10 though, obviously, because I'm only doing this experiment 10 times. Like I couldn't have, 11 successes when I'm only doing 10 trials of the experiment. So just keep that in mind. It has to be logical, right? So I'm gonna repeat the formula all the times I have to repeat it, and then add the probabilities together, and that will tell me what's happening. So the first time I do the experiment will be for 8, where R is 8. Okay, so in other words, I have to do the experiment for R is 8, I have to do it for R is 9, and I have to do it for R is 10, and then I have to get a sum. I should probably change colors here, right? How about purple? Okay, so let me put a line. Let me do a line here. Let me put a line here. And I'll redo my line for this too. Cool. Okay, so in the first experiment, okay, we have a 10 combination, but R is 8. That's 1/2 to the power of R. And then the failure rate, or probability, times 10 minus 8. Okay, so I didn't leave enough room for my answer, so that's awesome. Here's what I think I'm going to do. I'm going to get rid of this. And then I'm going to move all this stuff over. This is the beauty of doing your stuff on like a tablet, right? Oh, it moved my lines too. That's lame. Okay, hold on. Will it select all of them at once? Yes, it does. Fabulous. Okay, and then we can erase the red one. Like, let's have a beautiful example problem. You know what I'm saying? Like, what's the point in doing it non-beautiful? Like, okay, so we need to calculate this and figure out what it is. We also need to do a 10 combo of 9. So this is where r is 9. 1/2 to the power of 9. 1/2 to the power of 10 minus 9. That gives me some value. And finally, 10 combo 10. 1/2. 10. 1/2. What's 10 minus 10? 0. Okay, so let's calculate all this. Okay, now you're probably saying right now, like, oh my God, this is so much stuff to calculate. This is crazy. It's going to take me forever. I remember I told you there's an easy way to do this on the graphing calculator. I'm going to record a separate video on how to do it. Even if you don't have a graphing calculator, you'll be able to get this app on your phone for free that does all the same stuff for you, okay? And it's not photo math, I promise, because that's evil. Okay, so let's do this calculation. Can you see my calculator? Now you can. Now you see it, now you don't. Okay, so we need to do a 10 combo of 8. Multiply that answer by 1/2 to the power of 8. Multiply this answer by 1/2 to the power of 2, because 10 minus 8 is 2. Now, I'm not going to multiply it by 100 just yet. I'm just going to write the decimals down because I'm going to end up adding them together anyway. So the first answer is 0.0439. I think 3, that's probably enough places to be, specific enough. Okay, next problem. I'm not even going to put my calculator up here because you get the gist now, but 10 combo 9. Actually, I wonder if I can do this whole thing. I think I can. 1/2 power of 9, close that. 1/2 to the to the power of 1. Okay, and I get 0.0097. Okay, I found maybe what could be a faster way of entering this into the calculator. So if you look at my calculator screen, this is the entire second one right here where the R is 9. Okay, so that's the whole thing is written out, and I did get the correct answer. When you have to repeat these formulas over and over again, you can just use your arrow keys to roll up to it. Hit the enter key. You can't see me pointing to that, but there's an enter key at the bottom right corner. And it will copy and paste everything that you put in last time. And then you can just change the numbers. So if I go back here, my next one is 10. 10. And this is the power of 10. And this is the power of 0. And there's my crazy, ridiculous decimal. Okay, so lovely. We have to do another little lesson inside of this, like a mini lesson in a lesson, right? So I also need to tell you something about scientific notation. How about bright green, okay? I'm going to roll over to the side here, and I'm going to write what the answer on my calculator was. It's 9.765. That's enough places. And that was times 10 to the -4th, okay? On the calculator screen, you'll notice that I got 9.76 blah, 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 little e, -4. This is scientific notation. It's the same thing, okay? Times 10 to the negative fourth and e to the negative fourth. E negative 4. This is times 10 to the negative 4. It's scientific notation, all right? All this means is that to really figure out what this number is, we just need to move the decimal place to the left because it's negative. So where would I move the decimal if it was positive? To the right. So anytime that you see times 10 to the negative 4, I can look at this 9.765 and I can say, this is actually a really small number, and I know that because I need to move these decimal places. So let's move them, okay? 9.765. You move it 1, 2, 3, 4 places. And anytime there's a gap that doesn't have a number, you put a 0. Okay, so my final answer here is 0.000976, whatever. That's close enough, okay? This is crazy. Like, this, just so much work. Okay, the final answer is you just need to add all these together and multiply it by 100. So if I add them together, here is La Calculadora, 0.0439, 0.0097, 0.000976 times 100, 5.457. 5.457%. Okay, let's bring all of this full circle. Okay, so the problem was asking, if Kyle tosses a coin 10 times, what's the probability that he gets tails at least 8 times? Okay, so it makes sense to me that this probability is not super high, because to get 8, 9, or 10 of the tosses to be tails, okay, that's like the majority of the coin tosses, okay? The chances of that happening are pretty slim because there's nothing controlling the coin toss, you know what I'm saying? There's no other factors involved here. It's either a 50-50 shot, and every time you do it, you have a 50-50 shot. And for you to get tails, 8, 9, or 10, 80%, 90%, or 100% of those tosses to be tails, that's special. Okay, so it makes sense that this probability to me is very low, okay? Okay, let's regroup. Take a moment, take a deep breath. Go like this on your earlobes. Woosah, woosah. It's like calm down, all right? Zen breathing. So we have one more example problem, and then I'm going to set you loose on 11 and 12. Carol randomly chooses a day of the week 6 times. What's the probability of choosing Tuesday or Thursday at the most 3 times? Okay, this is dizzying. There's so many things to consider here. Okay, the first thing is I need to change the color of my pen because that's super important, okay? Like, how about, did I use red yet? How about orange? We're going to do orange for this one. Okay, so let's draw a little dividing line so we don't get all the math mixed up, all right? We're looking only at question number, in fact, I'm going to zoom question number 10 in, okay? Here's question 10, lovely. Okay, Carol randomly chooses a day of the week 6 times. So the number of trials Carol is doing is 6. She must be in quarantine because, like, who would be bored enough to actually try this experiment? Well, Carol is, okay? Whew. Okay. What is the probability of choosing Tuesday or Thursday at most 3 times? So this part, at most 3 times, means that my R value is less than or equal to 3, okay? I'm saying less than because the maximum number of times she can get a success here would be 3, which means she can also be successful 2 times or 1 time or no times, okay? So the probability of success would be choosing Tuesday or Thursday. So how many days of the week are there? 7. How many of those are Tuesday and Thursday? 2 of them. So the probability, okay, would be 2 out of 7, okay? 2, 7. That's like really hard to read because it's zoomed in so much. Maybe I need to make my pen not as thick. Okay, let me try that again. Oh yeah, that's way better to read, right? Okay. And our failure would be whatever's left, which would be 5 out of 7. Okay. All right. So we need to do the combinations for when there are 3 days, 2 days, 1 days, and 3 successes, 2 successes, 1 success, and 0 successes. So that's 4 formulas we have to calculate. Okay. Let's write them all out. I'm going to put a line here. We will write them all out. That's going to be 7 combo 3. My success rate is 2/7. That is 2 to the power of r. And then my failure is 5 out of 7. That's to the power of 6 minus r, n minus r, 6 minus 3, which is 3. Okay. And we're going to get an answer. I'm just going to fill in the rest of the formulas now. This might be a good strategy for you so you can keep all the information straight. It might make your calculations easier as well. The R value here is 2. This would be 6 minus 2, which is 4. Okay, 2/7. The R value is 1. This is 5/7 to the power of 6 minus 1, which is 5. Okay, this one's going to be 2/7 to the power of R. And this is 5/7 to the power of 6. Okay, now we just need to calculate. I'm gonna do this on my calculator the way I showed you last time with the just like copy and paste functionality. So we have a combination 7 combo of 3 times the fraction 2/7. I don't know why it's in subscript like that. Hold on. 7 combination. There we go. Times. So I had to hit the arrow key just now. Let me show you one more time. 7 combo 3. See how the little blinky, the cursor right here, is in the subscript still? When you're done with the combination part, make sure that you hit the right arrow so that it goes like regular print again. Okay, multiply this by 2/7 to the power of 3. Multiply this again by 5/7 to the power of 3. And there's your first answer, 0.297. We'll just leave it at 3 spaces. That's fine. Okay, I'm going to go up and hit enter to copy this over again, and let's fix the numbers. So the next one is 7 combo 2. Oh, you're probably like, wait a minute. Okay, I just realized I made a huge mistake, okay? Hold on. The issue here is that this value should be n, which is 6, and I put 7 because I was thinking like days of the week. I don't know what I was thinking. So let's actually fix that right now before I do any more of these. This should be 6, 6, 6. There we go, 6. Okay, fixed. My bad. Okay, so let's also get rid of this because that's wrong, and let's do it one more time. So this is actually 6. Okay, the first one is 0.1699. The second one is going to be 6 combo of 2. That's to the power of 2. That's to the power of 4. One more time, and then one more time after that. This is the power of 5. It's the power of 1. This is 1. Interesting. The answer came out exactly the same. Did I do something wrong here? No, I didn't. 6 minus 1 is 5. Yeah, okay. 3, 1. Interesting. 3, 1, 8, 7. Okay, one more time. And this time it's going to be 6, 0, and 0. Okay, sum all of these numbers right here, and you're going to have your final probability. Oops. And multiply that by 100. Okay, so my answer came out to 94.01%. And I just want to like check my logic and make sure that it makes sense. And it totally does. It totally makes sense. If she's randomly choosing a day of the week, 6 times she repeats this experiment, there's already a low probability of success because there's only 2 out of those 7 days that it could be, okay? And we're looking for, at most, at most 3 times. So we're saying that if 3 of those times she chooses a Tuesday or Thursday, it's this much. And then 2 out of those 6 times, it's this much. 1 out of those 6 times, it's this much. And 0 times, it's this much. Meaning in this last example, that means that she never picked Tuesday or Thursday, right? This sort of makes sense to me. This probability makes sense. It doesn't make sense if we were to go any higher than this, because if we, let's say for example, we were looking for the probability that she does it at the most 6 times, okay? Like the total number, if you found, well, that would be 100. Let's do like 5. Let's do 5 out of the 6 times. At most, out of 5 out of the 6 times, she picks Tuesday or Thursday. 5 out of those 6 experiments, you know, that whole cumulative probability is a lot. It would be different if we were looking only at a specific number, one of these scenarios. Like, for example, cover all this up and just look at this last one. If I asked you what's the probability that she never picks Tuesday or Thursday, you know, in this binomial experiment, this is 13% of the time. I mean, that's pretty low, and that makes sense. Okay. All right. So the 2 example problems at the bottom of this page are for you guys. Go ahead and check those out. And then there's going to be a Delta Math that goes along with this as well, so you can experiment, try it out, and look out for that separate video I'm going to post about the graphing calculator. If you guys have any questions or confusion, come to my office hours Tuesday and Thursday. That's from 10:30 to 1:30. Code will be posted on Google Classroom. And until next time, I will see you guys. Bye-bye.